Hi everyone, welcome back. In previous lectures, we have gone through several different GPU examples like vector addition, matrix multiplication, and sum reduction. Now I want to move to the profiling stage. In today's video, we're starting from the very simple example, the baseline of the vector addition. I think most of you, if you watched my previous videos, you're already very familiar with this example. And this is a hello world example of the GPU side. Let me bring the code here. I want to mention 2 points that I have added during this kind of program. Oh, by the way, this is a kind of command line that we will use for profiling in this video. The first point is we try to enlarge the vector size to 2 to the power 26 instead of 16. Sorry, the comment may not be correct. 2 to the 26, so that we can have a large vector size to have kind of more kind of calculations on the GPU kernels. A second point, instead of just doing the kernel once, we do it 100 times after the warm-up. Okay, so totally there will be 101 times of the kernel callings. This will help us to decrease the fluctuations of the profiling errors. When you just measure the thing once, you can get maybe a very small time or very kind of large time, but that's not your average status, right? Okay, so these are 2 points. And if you notice in previous videos, we're trying to do the compiling as well as running in the WSL2 side. Okay, so but now we have to switch back to the Windows PowerShell. Why? Because the Windows PowerShell is a Windows-based terminals and it can directly call the GPUs on the Windows. If you provide your program within WSL2, you can think of there is a kind of wrapper or the intermediate layer, right, between your program in a Linux system and the GPU in Windows system. So this kind of connections of the intermediate layers on both sides take some time, and that will make your profiling less accurate, right? That's why we switch back to the Windows PowerShell. That's first point. And also, if you see the compiler version, they're also different, at least on my system. So in the Windows PowerShell, I use the CUDA 11.2, but in the WS2, the examples we have shown before is 12.8. Even if both of them call the same Windows GPU drivers, the compiler version is different. There are some kind of history reasons because I want to run some kind of latest NVIDIA, some libraries, which needs me to install the kind of updated version of the CUDA. But in Windows system, we keep the CUDA 11.2. But anyway, it will not kind of influence the final profiling results, right? It will not influence the kind of conclusions that we obtain. Okay, so we have the compiler here. Then we can compile it. Okay, so the only thing I want to mention is that even if I have a kind of a good GPU, it supports SM89, but since we use the older compiler, it can only support the architecture SM86. That's why I use SM86 here. Okay, then you compile it. So after the compilations, you will get a bunch of files. Please just pay attention to this binary exe file. That's what we're going to focus on, or we're going to use to run our programs, right? Before do the profilings, you have to download some kind of tools from the NVIDIA library. So it is NVIDIA Insight. So Insight system. Please pay attention. Since I'm using Windows system, please just download the Insight system, right, for your for your Windows system instead of Ubuntu Linux system. That's very important. Otherwise, you can't do that. Yeah. Let me bring back Insight. Yeah. So here, Insight system. Uh, this is what we're going to use. Okay. After you download and install it, you can add its parts to the environment variables. So you can just call it from the command lines from terminals. Right. So we have the binary execution files. Now we need to run profile it. How to do that? Here it is. Okay, not this one. Sorry, this one. So previously we can just run the exe file, but now you have to add some prefixes before that to call the inside system. Okay, like this. So run. Okay. You can think of this tool as just sneak into your program and do some kind of profiling within that, right? And get a bunch of the time data and return that back to you. So that's this tool. Okay, and it can also generate some report like this, so you can open some of these reports from the GUI side. But in today's video, we're just trying to clarify some important numbers from the terminals. In the next videos, or maybe in future videos, I will try to um, uh, explain these numbers from GUI side, right, and see how we can use the inside. All right, so here we have a bunch of numbers, right? So basically divided in two parts. So the first part is the CUDA API sum. These numbers are kind of from the CPU side. And all of the following numbers, including the CUDA GPU kernel sum, mem time, mem size, all these things are from GPU perspective. Let's check the GPU perspective first. So in the CUDA GPU kernel sum, you see the instances is 101. So basically we call the vectorAdd kernel 101 times, right? And the average time is 2.91 millisecond. Okay, so that is the key number, 2.91 millisecond. And also for the memory kind of copy, so we copy two vectors from the CPU to the GPU from host to device. And after the calculation, we copy one vector from the device to host. And then you can have the average time, right? Average time for the, you see this kind of copy takes kind of maybe 8 or 9 times uh, uh, compared with kernel calculations, right? So that's a lot. And also the memory size. So still we copy two vectors from host to device and one vector back from device to host. And also the average vector size is fixed and it's 268 megabytes. So basically we can do a small calculations here. Let me clean it. So we have 268 megabytes for each vector. And during this process, we have 3 copies, right? So we can times 3. So it's kind of 804 megabytes. 84 megabytes. And the average time is 2.92. It divided by 2.92 kind of millisecond. So it's like this. So it's the final answer is about the 275 gigabytes for the kind of profiling memory kind of bandwidth, right? For this program. If you checked the some informations from the online, yeah. So this is my GPU at a generation laptop, 4000 RTX. You see the memory bandwidth is 432. So what we have used 275. Maybe it's 50 to 60%, right? Of the or 60 to 70%. I didn't do that. We can do it very quickly. We can 275 divided by 432. Yeah, so it's about 64% of the memory bandwidth that we can extract from this program. Okay, so that's the basic profiling. So basically, if you do not like the GUI side, you can just do your profiling here. And also for the CPU time, you can see most of the time is kind of consumed by the CUDA mem copy this function. And also the total time is even larger than the maximum time to copy this, to do this function, right? So basically there are some other kind of works like scheduling, controlling, and also maybe do the page division. This small tasks that takes sometimes uh, beyond the CUDA mem copy kernels. Yeah. So that's pretty much the providing information of these small examples. I hope this example can be a starting point for you to learn more knowledge about CUDA programming. Uh, you can also provide, right, the matrix multiplication and sum reduction examples, and I'm looking forward to your results. Yeah, thanks, and see you in the next video.